Okay, in question number 4, they're asking us to define an isotope. When we define an isotope, we will say that an isotope is when we have atoms of the same element that differ in their mass number. How do they differ in mass number? Well, they differ in number of neutrons. Because remember, our mass number is going to be the sum of the protons and the neutrons. How do they differ in protons? They don't. So same number of protons, different number of neutrons, and because they're neutral, if their protons are the same, then they must have the same number of electrons. Okay, so defining an isotope, it's atoms of the same element that differ in mass number. That difference in mass number is caused by a difference in the number of neutrons. So their protons are the same, their electrons are the same, but they differ in number of neutrons. Number 5 is asking us to complete the chart. Remember here that we have 8-man atomic number equals number of protons equals number of electrons in a neutral atom, and mass number minus atomic number equals number of neutrons. So for our sake, this is going to be our atomic number, this is going to be our mass number, this is number of protons, this is number of neutrons. Okay, so sometimes we ask you to do electrons in this type of chart as well. You certainly should be able to do that because we're only going to be dealing with neutral atoms, therefore the number of protons and electrons will be the same. In this table, we've only gone to proton and neutron. If we start with atomic number of 30, we know we also have 30 protons. If we know we have 30 protons and 30 neutrons, we add those together and get 67 for our mass number. That allows us to now do our isotope symbol. Recall that our isotope symbol has mass number on the top, 67, atomic number on the bottom, 30. We would go to our periodic table now, look up atomic number 30, and find out that is the element zinc, capital Z, small n. The next one has given us our isotope symbol. Therefore, the 77 on the top is our mass number. The 33 on the bottom is our atomic number. If our atomic number is 33, we know that that equals the number of protons, 33. To get number of neutrons, we're going to do 77 minus 33 and get 44. So the number of neutrons we have will be 44. Okay. Our next one, they gave us mass number, so we can put that up here on top, 131. They gave us number of protons, 53, so that can go on the bottom. We can look up element number 53 on the table, that is iodine. Since his proton number was 53, we know that's also the atomic number. To get neutrons, we will do 131 minus 53, and we will get 78. So that will be the number of neutrons. In the fourth example, we have neutrons and protons, so we have to add them to get mass number. So 52 plus 38 is a total of 90. So the mass number is 90. Our atomic number is equal to the number of protons, 38. When we do our isotope symbol, the mass number goes on the top, the atomic number goes on the bottom, and we look up number 38 on our table and find it is strontium. So strontium is going to be our last one. Giving the symbols for the following elements, Be sure when you give symbols, again, that we have a capital letter as the first one, and if there is a second letter, please be sure that it is lowercase. 10, number 50, SN. Titanium is our next one, number 22, TI. Gold is our next one. Gold's number 79, AU. Silver's right above him at number 47, AG. Argon's over at the far side, number 18, capital A, small r. Arsenic's down a little bit and over to the left, number 33, AS. Bromine's a little bit to his right, capital B, small r. And boron is upper and to the left a bit, capital B.